So you're going to find your critical point, find its first derivative, differentiate. Then let it to 0. Then you can simplify your 12. So x cubed minus x. Simplify it. Factorize your x. X squared. Here. So we can factorize x squared. So x squared equals to 0. X equals to 1. So x equals to 0. So what's your coordinate of y? When x equals to 0, coordinate of y is 1. When x equals to 1, coordinate y is 0. Therefore, we answer the first question, critical points are 0, 1 and 1, 0. Then we can move on to question B, finding out interval of increasing and decreasing. So we need our table. Using first derivative test, observe the gradient of tangent. So we need our interval. So later we test value. And then we look for the sign of first derivative. Lastly, conclusion. So how many intervals do we have here? When we're having 2 points, where x is equals to 0, another x is equals to 1. So our interval will be less than 0. And then between 0 and 1. After that, more than 1. So the test value will be a random value less than 0. We can choose -1, let's say. So this one we can choose 0.5. More than 1 we can choose 2. Then we're going to substitute inside our first derivative test here. Substitute into 12x cubed minus 12x squared. Observe whether it is positive or negative, that's all. So for this one is negative. So the gradient of the tangent is decreasing. When we substitute 0.5 also negative, so it is also decreasing. When we substitute 2, we get positive answer. So we get increasing. Therefore, for increasing interval, it occurs at x more than 1. For decreasing interval, it occurs at x less than 0 and x between 0 and 1. So from here, our question C, what is our extremum point? What is our maximum or minimum point? So we have a critical point here where x equals to 0, where x equals to 1. But we observe x equals to 0, it keeps on decreasing. So we can't say this one is maximum or minimum. Alright, so we only can observe it have a x equals to 1, before x equals to 1, decrease, after that it going up. So means at the point x equals to 1, which is 1, 0, it is a minimum point. Then we go for question D, where we want to find out inflection point. So when we need our inflection point, we need to find second derivative. So differentiate this again. Power turun tepat. Power tolak 1. So let second derivative equals to 0. And then we can notice that this quadratic can be simplified. We can divide by 12. Then we can factorize the x. So we might have an inflection point here, which is x equals to 0, x equals to 2 over 3. So once we get our x coordinate, we substitute to get our y coordinate. So x 0, y equals to 1. X equals to 2 over 3, y equals to 11 over 27. So we have 2 points here. 0, 1, 2 over 3, 11 over 27. There are inflection points. Then based on the value we have, we sketch the graph based on the coordinates we have, plot our point x-axis, y-axis, 0, 1. So 0, 1 here, 0, 1, 0, 1, 1, 0. So we notice that 0, 1 is inflection point, 1, 0 is minimum point, and then we still have another inflection point, 2 over 3, so in between here. 2 over 3, 11 over 27, so here. So we go for the minimum point first here. As we can see, this is minimum point. So you will have a concave outward to get minimum point. Betul? Then 2 over 3 dengan 11 over 27. This is inflection point when this concave outward bermaksud sini concave downward. So nampak inflection dia. Nampak macam S. Then when we come to 0 and 1, 0 and 1 also inflection point. So 0 and 1 here already concave downward. So means here will be concave upward. So lastly, label x-axis, y-axis, and our graph here. Y is equals to 3x power 4 minus 4x cubed plus 1.